Today you are going to learn how to transform figures using dilations. So first of all, what is a dilation? A dilation is a transformation that produces a similar figure to the original by proportionally shrinking or stretching a figure. So you're probably familiar with the term dilate. When you go to the eye doctor, sometimes they dilate your eyes. That just means they make your pupils larger so that they can better view the back of your eye. So here's a normal pupil, and then when you go to the eye doctor, they dilate it. They make that pupil in the center a lot larger so that they can see better. Here's a dilated PowerPoint slide. So I took the original and I dilated it. This time I shrunk it, I made it smaller. So again, your dilation is just a transformation of a pre-image that is similar to another image. When we dilate a figure, it must be proportionally larger or smaller than the original. It must be the same shape, but a different size or a different scale. So let's take a look. Here's a circle. This circle has a specific diameter, but we could shrink that circle, which decreases the size of the circle, but it also decreases the diameter. So here's a similar circle, but it's smaller than the original. And of course, if we increase that again, it would increase the diameter as well. So we could have enlarged the original. So we always have a circle with a certain diameter. We're just changing the size of that circle or the scale. So looking at these four pictures, we want to talk about which of these four are dilations. So here we have four things. We have a half gallon of milk and a gallon of milk. Oops. And these two right here are both dilations. So A is not a dilation because the milk containers are not the same shape. They are both milk containers, but they're not dilations of each other because, again, they're not the same shape. B is a dilation because they're both Bart Simpson. One of them is just smaller than the other one. Letter B with the snowflakes are exactly the same. One of them is just larger than the other one. And then letter D is not a dilation because your baby duck is not a smaller replica of the mother duck. It's not the same size and they do not look the same. So just because it's not the same size doesn't mean that it's a dilation. So when we talk about scale factor, if your scale factor is larger than 1, you're going to have an enlarged figure. If the scale factor is between 0 and 1, it's going to be a reduction in size. So scale factor greater than 1 makes things larger. Scale factor between 0 and 1 makes it smaller. So the length of each side of a new image is going to be equivalent to the length of the corresponding side of the original that's been multiplied by the scale factor. So looking here are the following enlarged or reduced. So if we look at letter A says we're going to have a scale factor of 1.5. So what that would do to this picture is exactly this. It's going to make it larger. So there, our picture got enlarged. Letter B, we have a scale factor of 0.75. That means our picture of our elephant is going to be reduced in size just like that. Letter C, we have a lion with a scale factor of 3. A scale factor of 3 would enlarge our diagram. And then letter D, we have 2 parrots. I believe they're parrots. With a scale factor of 1/5. A scale factor of 1/5 is 0.2, which is less than 1. So we would reduce the size of that picture. So dilations are used in everyday life. So here we have a picture over on the top left of the world's largest arcade game. It's enlarged in size just for fun. In the top middle, we have a picture of some toy cars. Those are reduced in size for children to play with. On the top right, we have a large chair. That chair was enlarged to capture attention for a furniture store. We take maps and we reduce them in size for practicality. We can't use a map unless we can see the whole thing, so it's been reduced in size. The bottom middle, we have a model of a new building. Those are reduced in size for being able to see the overview of a building for some models. And then the last one, we have a large burger. It's been enlarged in size for fun, for photo opportunities, or to promote a business. So looking here, we're going to read this. So the dashed line is a dilation image of the solid line figure. The labeled point is the center of dilation. Tell whether this is an enlargement or a reduction, and then find the scale factor of the dilation. So looking at question number 1 here, again, we're going to determine whether this is an enlargement or a reduction. So if I look here, the dotted line represents the either enlarged or reduced figure. So looking at question number 1, we have this triangle here, and the dotted image is going to be an enlargement. And then to figure out the scale factor, we're going to take the dashed measure and we're going to divide it by the solid of the corresponding side. So these two correspond to each other. I'm taking the dotted divided by the solid, so 8 divided by 4 gives me a scale factor of 2. So here the scale factor for question number 1 is 2. Take a moment and see if you can do question number 2. So question number 2 is an enlargement. The solid figure has been enlarged to become the dotted figure. And then again, we're taking the length of the dotted or the dashed side. So the dashed side has a length of, if this right here is 6 and this right here is 3, so the enlarged side has a length of 3 plus 6, or 9. And then for the solid side just has a length of 3, and then 9 divided by 3 is 3. So here we have an enlargement and the scale factor is 3. Looking at question number 3, the original image is in the solid line, and then our dotted or our dashed figure is the second one. So this figure has been reduced. So this is a reduction. Our figure is getting smaller from the solid to the dotted. And then if I figure out the scale factor, I'm taking the dashed line divided by the solid. So I'm taking 6 divided by 9, which reduces to 2/3. So the second figure is 2/3 the size of the original. And then last one, letter D, we're going from the original solid figure to the dotted. That is an enlargement. To figure out the scale factor, we're taking the length of the dash side divided by the solid side. If this right here is 4 units and this right here is 4 units, that means the total length of the enlarged side is 4 plus 4, which is 8, divided by the original solid length side, which is 4. We have a scale factor of 2. Next, we have a dilation with a center of 0, 0, and for this class, that is all we're going to use. So we're dilating from the center of the coordinate plane. Then we're going to find each point for the given scale factor. So for question number 5, we have point B located at 2, 3. To figure out the new ordered pair, we're going to take each point and we're going to multiply it by the scale factor. So each part of our ordered pair is going to get multiplied by that scale factor. So instead of B, we're going to have B prime because we're moving it. So B with a little apostrophe. So B prime is at the ordered pair. 2 times 6, our scale factor. 2 times 6 is 12. And then 3 times 6, 3 times our scale factor of 6 is 18. So given the scale factor of 6, the ordered pair 2, 3 would move to the ordered pair B prime, which is at 12, 18. For question number 6, we have this time a reduction of 2/5. To figure out A prime, we're going to multiply the original ordered pair by 2/5. So when I take 0 times 2/5, remember when we take 0 times 2/5, really we can just make both of them a fraction and multiply straight across. So 0 times 2 is 0, divided by 1 times 5, which is 5, gives me 0 for that x value. So for that one, the x-coordinate doesn't move, it stays at 0. For the y-coordinate, we're going to take -5, make it a fraction, -5/1, and then we're going to multiply it by the scale factor 2/5. That gave me a fraction of -2/5, which reduces to -2. So now A prime is going to be located at 0, -2. And again, we got that by multiplying each part of the coordinate by the scale factor. So for example 7, we're going to graph a pentagon PENTA and its image P prime, E prime, N prime, T prime, and A prime for dilation with a center 0, 0, and then a scale factor of 0.5. So it tells us the vertices are P, 0, 4. So we're going to take and we're going to graph 0, 4 first. So 0, 4 goes right here. And I'm going to label that P. If I want a dilation of 1/2 to find P prime, I'm going to take 1/2 times both of those values. So 1/2 times 0 is 0. 1/2 times 4 is 2. So P prime, I'm going to do in red, is going to be at 0, 2. And then I'm going to label that P prime. Then I'm moving on to letter E. E is an ordered pair 6, 6. So there's 6, 6. I'm going to label it E. And then I'm going to find the dilation, in this case reduction, for letter E. So E prime is going to be the ordered pair 6, 6 reduced by a scale factor of 0.5. So 0.5 times 6 is 3. So I'm going to have the ordered pair 3, 3. And again, I'm going to label that E prime. So that prime just tells us I've taken the original point and I've either reduced it or enlarged it. In this case, I've reduced it in size. To find n, I'm going to 40. 40 is up here, and I'm going to label it n. To find n prime, I'm going to take those two vertices and I'm going to multiply them by 0.5. So 4 times 0.5 is 2, and 0 times 0.5 is 0. So n prime is going to be located at 2, 0, again labeling it n prime. Two more. So letter T is located at 0, -4. So I'm going to label that T. So start at the origin. 0 tells us left or right, none. And then -4 tells us to go down 4. To find T prime, I'm going to take both of those ordered pairs, or both coordinates of that ordered pair, and multiply it by 1/2. 0 times 1/2 is 0, and 0 times -4 is -2. So T prime is going to be right here at 0, -2. The last order pair we need to talk about is A. A is currently located at -2, 0. So I'm going to graph that and label it A. And then the last thing I want to do is take -2, 0, and multiply it by 1/2. When I multiply -2 by 1/2, I get -1. When I take 0 and multiply it by 1/2, I get 0. So A prime is going to be at the ordered pair -1, 0, and I'm going to label that A prime. So the last thing I want to do for my graph is to go ahead and connect the sides of this figure to make our diagram. Keep in mind your figures should look exactly the same as one another, except one should be enlarged in size. So here my blue figure, so my pentagon in blue is the original. My dilation, which happens to be a reduction in size, is the red. This one here, we have triangle STU with these vertices and a scale factor of 1/3. So take a moment and pause the video and see if you can draw the original triangle, and in this case, the reduction by 1/3. So here I've went ahead and drawn in the original triangle STU, and now we're going to fill in the coordinates for S prime, T prime, and U prime. So to find S prime, we need to take the ordered pair -15, -3 and multiply it by 1/3. So 1/3 times -15 is -5. And -3 times 1/3 is -1. So S prime is now going to be located at -5, -1. So right there, and then I'm going to label it S prime. For ordered pair T, I have -12, -15. I'm going to multiply that by 1/3. So when I multiply -12 times 1/3, I get -4, and -15 times 1/3, I get -5. So I'm going to the order pair -4, -5. And that's going to be T prime. And the last order pair, 0, -9. When I multiply 0 times 1/3, 0 times 1/3 is 0. And -9 times 1/3 is -3. So this order pair, 0, -3, is going to be U prime. And then to finish things up, I'm going to connect all three of these to make a triangle. Keep in mind, my original triangle should be larger than my second figure because it should have been reduced in size. So since I've reduced it, my reduced picture should be smaller than the original. One last thing you might be asked to do for this section is to identify the scale factor that's been used in the graph. So my favorite way to do this is to figure an ordered pair